Have you ever looked up at the night sky and wondered if we are truly alone, not just in the universe, but here on our own planet throughout its vast history? Tonight, we embark on a journey that will challenge everything you think you know about Earth's timeline and our place within it. Close your eyes and let your mind drift as we explore one of the most fascinating questions in science. What if an advanced civilization thrived on Earth millions of years before the first dinosaur ever drew breath? Picture yourself standing on a mountaintop, gazing across landscapes that seem eternal and unchanging. The rocks beneath your feet feel solid, permanent, as if they have always been there. But these stones hold secrets that span unimaginable stretches of time. They whisper stories of worlds so ancient that they existed when our planet was an entirely different place, populated by creatures we can barely fathom. Most of us think of history as something that began with writing, perhaps 5,000 years ago in ancient Mesopotamia. We might stretch our imagination back to the first cave paintings, maybe 40,000 years into the past. The truly adventurous among us consider the dawn of humanity itself, reaching back a few 100,000 years. But even this expanded view captures only the tiniest sliver of Earth's true story. Our planet has been spinning through space for 4.5 billion years. To put this in perspective, imagine compressing all of Earth's history into a single day. If our planet formed at the stroke of midnight, the first simple life wouldn't appear until around 6 in the morning. Complex creatures with shells and bones wouldn't show up until nearly 10 at night. Dinosaurs would rule for just the final hour before midnight. And humans? We would appear in the last few seconds before the day ends. This perspective shift opens up vast territories of time that we rarely consider. If Earth has been a living world for billions of years, experimenting with countless forms of life, then why do we assume that intelligence could only emerge once? What if the story of consciousness on our planet is far older and more complex than we dare to imagine? The idea might sound like fantasy, but it has captured the attention of serious scientists. Researchers have begun to ask uncomfortable questions about what we might have missed in our understanding of the deep past. They wonder whether traces of ancient intelligence could be hiding in plain sight, embedded in rock layers that formed hundreds of millions of years ago. Consider the challenges we face when trying to understand even recent history. Entire civilizations have vanished from human memory, leaving behind only scattered ruins and fragments of pottery. If we struggle to piece together the stories of cultures that existed just a few thousand years ago, how much more difficult would it be to detect signs of intelligence from the truly ancient past? The Earth is not a museum that carefully preserves everything for future discovery. It is a dynamic, restless world that constantly reshapes itself. Continents drift across its surface like massive rafts. Mountains rise and erode away. Oceans expand and contract. The sea floor gets recycled back into the planet's interior. Most of what once existed on the surface has been ground down, buried, melted, or scattered by geological forces operating over millions of years. This process of erasure becomes more complete as we look deeper into time. The rocks that survived from hundreds of millions of years ago represent only tiny fragments of what once was. They are like scattered pages from a vast library, with most of the books missing entirely. Within these gaps in the geological record, entire chapters of Earth's story may have been lost forever. But what kind of world existed before the dinosaurs? Most people imagine the distant past as a primitive place, populated by simple creatures crawling through primordial swamps. This picture is far from accurate. Long before the first dinosaur appeared, Earth was already home to complex ecosystems teeming with life. During the Carboniferous period, more than 300 million years ago, vast forests of giant ferns and towering trees covered the landscape. The atmosphere contained more oxygen than it does today, allowing insects to grow to enormous sizes. Dragonflies with wingspans wider than a hawk soared through humid air. Millipede-like creatures longer than a person scuttled across the forest floor. Amphibians the size of crocodiles lurked in ancient swamps. This was not a barren or empty world waiting for evolution to get started. It was a planet already rich with biodiversity, complex food webs, and intricate ecological relationships. The raw materials for intelligence were already present. Complex brains, sophisticated sensory systems, and social behaviors had all appeared in various lineages. If evolution had taken slightly different turns, if environmental pressures had pushed in different directions, could one of these ancient lineages have developed something resembling civilization? The question becomes even more intriguing when we consider how evolution actually works. It is not a ladder leading inevitably toward human-like intelligence. Instead, it is an endless experiment, trying countless variations and filling every available niche. Over hundreds of millions of years, life has tested almost every conceivable strategy for survival. Some creatures became faster, others stronger, still others more camouflaged. A few developed larger brains and more complex behaviors. Intelligence itself exists on a spectrum that we can observe in the modern world. Octopuses solve puzzles and use tools. Crows craft implements to extract food from tight spaces. Dolphins have complex social structures and communication systems. Ants build sophisticated societies with division of labor and collective decision-making. These examples remind us that clever, adaptive behavior is not unique to humans. What makes our species unusual is not intelligence alone, but the combination of intelligence with culture and technology. We don't just solve problems. We pass solutions to our children, who build upon them to create even more sophisticated tools and ideas. This cumulative process has allowed us to transform from a species of hunter-gatherers to builders of cities and spacefaring civilizations in just a few thousand years. Yet this breakthrough required a very specific set of circumstances: the right environment, the right evolutionary pressures, and perhaps a good deal of luck. Over Earth's long history, similar conditions may have arisen multiple times. Different lineages might have stumbled upon the same breakthrough, developing their own versions of culture, technology, and civilization, only to vanish when environmental catastrophes reset the biological clock. The fossil record shows us that mass extinctions have repeatedly swept across our planet, erasing dominant life forms and clearing the stage for new experiments. The most famous of these events ended the age of dinosaurs 66 million years ago, but earlier extinctions were even more devastating. The Great Dying, which occurred 252 million years ago, eliminated more than 90% of marine species and 70% of terrestrial species, percent of land-dwelling vertebrates. It was a reset button pressed on a planetary scale. If intelligent civilizations had emerged before these catastrophic events, they would have faced the same fate as the countless species that perished. Their cities would have been buried under volcanic ash or swept away by climate collapse. Their technologies would have corroded and decayed. Their very species might have been driven extinct, leaving no descendants to remember their achievements. This raises a haunting possibility. What if the story of intelligence on Earth is cyclical rather than linear? What if consciousness has emerged multiple times throughout our planet's history, only to be extinguished by the same forces that regularly reshape the biological world? We might be not the first chapter in the story of earthly intelligence, but merely the latest. The evidence for such ancient civilizations would not look like what we typically expect from archaeology. There would be no pyramids or temples surviving from hundreds of millions of years ago. No pottery shards or metal tools would remain intact across such vast spans of time. Instead, the traces would be subtle. Unusual chemical signatures in rock layers, strange isotopic ratios that don't match natural processes, or fossil patterns that suggest rapid changes in ecosystems. Some scientists have proposed that we should look for what they call technofossils, the long-term environmental impacts that industrial civilizations leave behind. Our own species is already creating such markers. We are altering the chemistry of the atmosphere and oceans, driving species extinct at accelerated rates, and spreading synthetic materials across the globe. Future geologists studying rock layers from our time will find clear evidence of dramatic environmental change. If an ancient civilization had similarly transformed its environment, some traces might still be detectable today. A sudden spike in certain metals or isotopes, rapid climate shifts recorded in ancient sediments, or mass extinction events that coincided with other anomalies could all potentially point toward technological activity in the distant past. Of course, distinguishing such signals from natural processes presents enormous challenges. Volcanic eruptions, asteroid impacts, and other geological events can produce many of the same signatures that we might expect from industrial activity. The deeper we look into time, the more difficult it becomes to separate artificial patterns from natural ones. This uncertainty is part of what makes the question so compelling. We are forced to confront the limits of our knowledge and acknowledge how much of Earth's story remains hidden from us. The rocks preserve only fragments, and those fragments can be interpreted in multiple ways. What looks like evidence of intelligence to one researcher might appear completely natural to another. As you drift toward sleep tonight, Let your mind wander through these vast corridors of time. Imagine walking through forests of giant ferns, breathing air thick with oxygen, listening to the calls of creatures that have no names in our modern world. Picture civilizations rising and falling like waves on an ocean of time, each leaving barely a whisper of their existence before being swept away by the next great catastrophe. Whether such civilizations ever existed remains an open question, one that science may never definitively answer. But in asking it, we gain something valuable, a deeper appreciation for the immensity of our planet's history, and a humbling recognition of how brief our own moment in that history truly is. The silence of deep time surrounds us like a gentle blanket, but within that silence lie whispers of possibilities that stretch our understanding beyond its comfortable boundaries. As your breathing slows and your thoughts begin to drift, consider how the very concept of evidence changes when we peer back across hundreds of millions of years. Think about a single footprint left in wet sand beside a lake. Within hours, waves wash it away. Within days, wind fills any remaining depression. Within years, the entire shoreline may have shifted. Now multiply that erasure by millions and millions of years, and you begin to understand why detecting ancient intelligence presents such extraordinary challenges. The earth beneath us is not the solid, unchanging foundation it appears to be. It breathes and shifts like a living thing, constantly remaking itself through processes that dwarf human timescales. The ocean floors, which we might imagine as permanent features, are actually young by geological standards. Most are less than 200 million years old, because the planet continuously recycles them back into its molten interior. Continental land masses drift across the surface like enormous ships, carrying their cargo of rocks and fossils to entirely different climates and locations. Mountains rise grain by grain over millions of years, only to be worn down just as slowly by wind and rain. Rivers carve valleys that later become filled with sediment, creating new landscapes over the bones of the old. This constant reshaping means that the surface world of 300 million years ago bears little resemblance to what we see today. The continents were arranged differently. The climate was warmer, and vast swamp forests covered regions that are now deserts or ocean floors. If cities had existed in that ancient world, they would have been ground down by the same relentless forces that shape all of Earth's features. But perhaps we are thinking about this problem in the wrong way. Perhaps the question is not whether we can find intact ruins from the deep past, but whether we can detect the subtle fingerprints that any technological civilization would inevitably leave behind in the geological record. Consider what traces our own civilization will leave for future archaeologists to discover. Our concrete and steel may crumble within centuries, but other markers will persist far longer. The carbon dioxide we pump into the atmosphere creates a distinctive chemical signature that will remain visible in rock layers for millions of years. The plastics we manufacture break down into microscopic particles that become incorporated into sediments around the world. The metals we mine and distribute globally create unusual concentrations of elements that rarely occur together in nature. Our nuclear technology produces radioactive isotopes that do not exist in the natural world, some of which will remain detectable for extraordinarily long periods. Even our agricultural practices leave lasting marks, creating sudden changes in pollen records and soil chemistry that future scientists could recognize as artificial. Most significantly, our activities are driving what many scientists consider the sixth major mass extinction in Earth's history. This biological upheaval will leave a clear signature in the fossil record, marking our era as a time when the normal patterns of evolution were dramatically disrupted. If we extrapolate this forward, future geologists studying rock layers from our time will find evidence not of our cities or technologies, but of rapid environmental change, unusual chemical concentrations, and biological disruption. They might not immediately recognize these patterns as signs of intelligence, but careful analysis could reveal that natural processes alone cannot explain the sudden shifts they observe. Working backwards from this understanding, we might ask whether similar signatures exist in much older rock formations. Are there layers from the deep past that show unexpected chemical anomalies, rapid climate changes, or mass extinction events that resist easy explanation through purely natural causes? The answer is both intriguing and frustrating. Such anomalies do exist scattered throughout the geological record. There are ancient rock layers with unusual metal concentrations, unexplained isotopic ratios, and evidence of rapid environmental changes that occurred over relatively short periods. Some of these patterns have been linked to volcanic eruptions, asteroid impacts, or other natural catastrophes. Others remain mysterious. The challenge lies in distinguishing between what nature can produce on its own and what might require the intervention of intelligence. Volcanic eruptions can create many of the same chemical signatures we associate with industrial activity. Asteroid impacts can drive mass extinctions and climate change. Even the movement of continents can create unusual concentrations of minerals and metals in specific regions. This ambiguity is compounded by the incompleteness of the geological record itself. We have access to only tiny fragments of ancient rock formations, scattered across the globe like pieces of a vast jigsaw puzzle with most of the pieces missing. Within these gaps, almost anything could have happened without leaving traces we would recognize today. The situation becomes even more complex when we consider how our own assumptions shape what we look for and how we interpret what we find. We search for signs of technology that resemble our own, but an ancient civilization might have developed along entirely different paths. Their energy sources, materials, and environmental impacts could be so unlike ours that we would not recognize them as artificial. Imagine a civilization that developed sophisticated biotechnology instead of metallurgy, growing their tools and structures rather than forging them. Or consider beings that harnessed geothermal energy so efficiently that their industrial activities mimicked natural geological processes. Such civilizations might leave traces that we would classify as biological or geological phenomena, rather than technological artifacts. The timescales involved also work against detection in subtle ways. Even if an ancient civilization had existed for millions of years, that entire span would represent just a thin slice in the geological record. The layers of rock that preserve evidence from such periods might be only a few meters thick, and they could be buried beneath kilometers of younger sediments, or scattered across multiple continents by tectonic activity. Moreover, the processes that create fossils and preserve other traces in rock work best for certain types of materials and environments. Bones and shells fossilize more readily than soft tissues. Sediments deposited in lakes and shallow seas preserve evidence better than those formed on dry land. The technologies and activities of an ancient civilization might have been concentrated in environments that are least likely to produce lasting geological records. As you settle deeper into rest, let your imagination explore these possibilities without the constraints of certainty or proof. Picture vast libraries of crystalline memory storage that would appear to future geologists as nothing more than unusual mineral formations. Envision transportation systems based on magnetic levitation that would leave no trace except subtle alterations in the magnetic properties of certain rocks. Consider energy technologies that worked in harmony with natural processes, drawing power from the Earth's rotation or the movement of tides in ways that enhanced rather than disrupted existing systems. Such approaches might actually stabilize ecosystems and climate patterns, making them invisible to our methods of detection that focus on environmental disruption as a marker of technological activity. The beings themselves might have been so different from us that their entire approach to civilization defies our categories. Perhaps they were aquatic intelligences that built their greatest achievements in the deep ocean basins, which have since been sub-intelligences like advanced versions of ant colonies that created structures abducted back into the planet's interior. Maybe they were collective, would interpret as natural formations rather than artificial constructions. The more search for ancient intelligence is constrained by our assumptions about what intelligence looks like and how it expresses itself in the physical world. We explore these possibilities, the more we realize how much about what kind of crime we are investigating, or even whether AIist fragments of evidence, while simultaneously being uncertain. Detectives trying to solve a crime using only the 10 crime occurred at all. This uncertainty is not a failure of science, but rather an honest acknowledgement of the limits of knowledge when confronted with the vastness of deep time. The geological record is like a book with most of its pages missing, written in a language we are still learning to read, describing events so far removed from our experience that we struggle to imagine them clearly. Yet, within this uncertainty lies a profound sense of wonder. The very fact that we can ask these questions, that we can peer back across hundreds of millions of years and speculate about the possibility of forgotten worlds, speaks to something remarkable about consciousness itself. We are the universe becoming aware of its own history, even as that history remains partially hidden from us. Whether ancient civilizations existed before the dinosaurs may ultimately matter less than the journey of exploration itself. In wrestling with these questions, we expand our conception of what is possible, challenge our assumptions about uniqueness and permanence, and develop a deeper appreciation for the complexity and mystery of the world we inhabit. The night sky above us contains countless stars, many of them orbited by planets that may harbor their own experiments in intelligence and civilization. As we drift between waking and sleeping, we can imagine ourselves as part of a vast community of conscious beings, separated not just by space, but by immense stretches of time, each struggling to understand their place in an ancient and ever-changing cosmos. The silence of ancient worlds calls to us across the abyss of time, but within that silence lie traces so subtle that they challenge our very understanding of what evidence means. As you continue to drift deeper into restful contemplation, let your mind journey through the labyrinth of possibilities that emerge when we consider how intelligence might have manifested in ways completely foreign to our experience. Picture yourself as a time traveler standing in a world from 300 million years ago, breathing air so rich in oxygen that flames would burn with impossible intensity. The landscape around you pulses with life forms that defy easy categorization. Massive arthropods scuttle through undergrowth taller than modern trees. In the distance, something that might be mistaken for a log suddenly moves, revealing itself as a creature whose lineage will vanish completely before the first dinosaur draws breath. But what if, among these alien forms, something else moved through that ancient landscape? Something that watched the world with calculating eyes, that experimented with tools, that passed knowledge from one generation to the next. The evidence for such beings would not announce itself with the clarity we might hope for. Instead, it would whisper through the geological record in languages we are only beginning to learn how to hear. Consider the story that rocks tell about the chemistry of ancient atmospheres. Every breath taken by every creature that ever lived has left its mark on the carbon cycle. The shells of ancient sea creatures preserved the chemical signature of the water they grew in. Ice cores trap bubbles of air from thousands of years past. These records paint pictures of environmental conditions stretching back through deep time. But they also reveal something more intriguing. Moments when the normal patterns were disrupted by forces that resist easy explanation. There are periods in Earth's history when carbon isotope ratios shifted dramatically over relatively short geological time frames. Some of these changes coincide with known volcanic eruptions or asteroid impacts. Others remain puzzling. The conventional explanation attributes most anomalies to natural processes, but the patterns sometimes bear striking resemblances to what we might expect from large-scale industrial activity. Imagine a civilization that burned vast quantities of organic matter for energy, just as we burn fossil fuels today. The carbon released would carry a distinctive isotopic signature, one that would remain detectable in sedimentary layers for millions of years. Such a signature would look almost identical to what volcanic activity might produce, but subtle differences in the pattern of change might reveal its artificial origin to sufficiently careful analysis. The challenge lies in the fact that geological processes operate on scales that dwarf human experience. What seems like a sudden change in the rock record might actually represent thousands or even millions of years of gradual shift. Conversely, the events that unfolded over centuries or millennia leave signatures so thin that they can easily be overlooked or misinterpreted. This compression of time creates a peculiar kind of blindness. we can detect massive environmental changes that occurred over millions of years, but we struggle to see rapid transformations that might have been driven by technological activity. It is like trying to understand a conversation by hearing only every 100th word, spread out over hours of listening. The fossil record compounds this difficulty by preserving only the tiniest fraction of the life that once existed. Most creatures that die leave no lasting trace whatsoever. Their bodies decompose, their bones scatter, their very existence fades into the endless recycling of biological materials. Only under exceptional circumstances do remains become fossilized, and even then, the resulting specimens often consist of fragments that require careful interpretation. If intelligent beings had lived in the ancient world, their own bodies would have been subject to the same processes of decay and erasure that claim all organic matter. Unless they possessed some quality that made fossilization more likely, or unless they developed technologies for preserving their remains, we would expect to find few, if any, direct traces of the beings themselves. But intelligence leaves marks that extend far beyond the physical forms of the creatures that possess it. The most enduring signatures of consciousness might be found not in fossils of ancient beings, but in the patterns of change they imposed upon their environment. A truly advanced civilization would have reshaped the world around it in ways that persist long after the civilization itself had vanished. Consider how our own species has altered the distribution of elements across the planet's surface. We have moved vast quantities of metals from deep underground deposits to the surface, where they become incorporated into soils and sediments. We have created new chemical compounds that never existed in nature, some of which will persist in detectable quantities for geological ages. Future scientists studying our era will find layers of sediment containing unusual concentrations of rare earth elements, synthetic polymers, and radioactive isotopes that can only be explained by technological activity. These chemical fingerprints will remain visible long after every building has crumbled and every artifact has been ground to dust by erosion. Working backward from this understanding, we might ask whether similar chemical anomalies exist in much older geological formations. Are there ancient layers that contain unexpected concentrations of metals, unusual isotopic ratios, or synthetic compounds that natural processes alone cannot explain? The answer is both tantalizing and frustrating. Anomalous chemical signatures do exist in rocks from the deep past, but interpreting them requires extraordinary care. Natural geological processes can create patterns that closely mimic what we might expect from technological activity. Distinguishing between artificial and natural origins becomes increasingly difficult as we peer further back in time. Certain types of evidence might prove more durable than others. Radioactive elements with very long half-lives could preserve traces of nuclear technology for hundreds of millions of years. Crystalline structures, formed under artificial conditions, might retain their distinctive properties across vast stretches of time. Patterns of mineral distribution that reflect large-scale mining and processing operations could remain detectable even after the landscapes themselves had been completely transformed. The search for such evidence requires techniques that push at the very edges of analytical chemistry and geological dating. Researchers must develop methods sensitive enough to detect tiny anomalies buried within the noise of natural variation, while simultaneously being rigorous enough to distinguish genuine signals from experimental artifacts or contamination. Even if such traces were discovered, proving their artificial origin would present enormous challenges. The scientific community rightly demands extraordinary evidence for extraordinary claims. Any purported sign of ancient intelligence would be subjected to intense scrutiny, with researchers exploring every possible natural explanation before considering technological origins. This conservative approach serves science well, protecting it from premature conclusions and ensuring that new ideas are thoroughly tested before acceptance. But it also means that evidence for ancient civilizations might need to be overwhelmingly clear and abundant before it would be widely accepted. Subtle hints and suggestive patterns, no matter how intriguing, might never be sufficient to establish such a revolutionary conclusion. The implications of discovering ancient intelligence would extend far beyond archaeology or geology. They would fundamentally alter our understanding of evolution, consciousness, and our place in the cosmic story. If intelligence had emerged multiple times on Earth, it would suggest that consciousness might be a more common outcome of evolutionary processes than we currently believe. This possibility carries both hope and warning for our own future. Hope, because it would suggest that intelligence is not a unique accident, but rather a natural expression of complexity that emerges given sufficient time and opportunity. Warning, because it would also demonstrate that even advanced civilizations can vanish completely, leaving behind only the faintest traces of their existence. As you drift deeper into the realm of dreams, let your imagination explore worlds where intelligence took forms we can barely conceive. Picture beings that thought in geological time, making plans that spanned millions of years and creating works of art that were invisible to any perspective shorter than eons. Envision civilizations that achieved perfect harmony with natural processes, leaving behind improvements rather than disruptions. Consider the possibility that consciousness itself might be older than we imagine, that the capacity for self-awareness and creative thought has been experimenting with different forms of expression throughout Earth's long history. Perhaps we are not the first chapter in the story of intelligence, but merely the latest experiment in an ongoing exploration of what it means to be aware. The question of ancient civilizations before the dinosaurs may never receive a definitive answer. The evidence, if it exists, might be too subtle or too scattered for our current methods to detect. But in pursuing the question, we expand our understanding of deep time, geological processes, and the remarkable resilience of information across vast stretches of history. Whether or not intelligence arose before our own lineage, the mere possibility reminds us of how much mystery still surrounds us. We inhabit a planet whose history stretches back billions of years, most of which remains hidden behind veils of time and geological transformation. Within that hidden history lie countless stories of rise and fall, experimentation and extinction, success and failure on scales that dwarf our comprehension. The rocks beneath your feet have witnessed wonders that no human eye has ever seen. They have felt the weight of creatures whose names will never be known, absorbed the chemistry of atmospheres unlike any that exist today, and recorded the signatures of processes that operated long before our solar system had settled into its current configuration. As sleep begins to claim your consciousness, carry with you this sense of vast possibility. The universe is far stranger and more wonderful than we often allow ourselves to imagine. Time itself is deeper than we can fathom, filled with chapters of history that may never be fully recovered, but whose influence continues to shape the world we inhabit. In the silence between heartbeats, in the pause between thoughts, in the gentle transition from waking to sleeping, we touch something that connects us to all the conscious beings who may have preceded us. Whether they existed millions of years ago or in civilizations yet to come, we share with them the remarkable gift of awareness, the capacity to wonder about our place in the unfolding story of existence. The night embraces you now with the same darkness that has cradled countless generations of dreamers, each one gazing up at stars that have shone down on worlds we can only imagine. Rest now in the knowledge that you are part of something magnificent and mysterious, a story that began before memory and will continue long after our current chapter has ended. The whispers of ancient worlds grow stronger as we delve deeper into the mysteries that surround us. In your peaceful state between waking and dreaming, imagine yourself as a detective of deep time, searching for clues that may have been waiting millions of years to be discovered. The evidence we seek exists not in grand monuments or gleaming artifacts, but in the subtle chemistry of stones and the delicate patterns preserved in layers of sediment. Think of the earth as an enormous library, but one where most of the books have been torn apart and scattered by wind and weather. The pages that remain are written in a language of minerals and isotopes, telling stories in chemical dialects that we are still learning to interpret. Each rock layer represents a chapter from this vast chronicle, though many chapters have been lost entirely to the relentless editing of geological time. When we examine these surviving fragments, we occasionally find sentences that seem out of place, paragraphs that don't quite fit the narrative we expect. These are the anomalies that capture our imagination and challenge our understanding. Perhaps they represent nothing more than the creative power of natural processes, which can craft patterns so intricate and unexpected that they seem almost intentional. Or perhaps, just perhaps, they preserve the faintest echoes of intelligence from epochs so distant that they precede our entire evolutionary lineage. The challenge of interpretation becomes even more complex when we consider how radically different an ancient civilization might have been from our own. We tend to imagine intelligence in terms that reflect our human experience, but consciousness could have emerged along pathways that bear no resemblance to our technological development. Where we see the absence of familiar artifacts, there might once have been forms of organization and creation that operated according to entirely different principles. Envision beings that learned to work with biological systems rather than against them, creatures that discovered how to guide evolution itself as their primary technology. Their greatest achievements might have been living ecosystems that functioned as vast, distributed networks of intelligence. Such creations would appear to us as nothing more than particularly complex natural habitats, their artificial origins hidden beneath millions of years of continued biological evolution. Consider civilizations that harness the planet's own energy flows, tapping into the magnetic field, the rotation of the core, or the tidal forces generated by celestial mechanics. Their infrastructure might have been indistinguishable from geological formations, integrated so seamlessly with natural processes that we would never recognize their artificial nature. The mountains themselves might have been their monuments, sculpted over millennia to serve purposes we cannot even imagine. The beings responsible for such achievements might have thought in time frames that dwarf our comprehension. Where we measure progress in years or decades, they might have planned in geological ages, implementing changes so gradually that each generation would perceive their world as entirely natural. Their influence could have shaped the very evolution of life on Earth, guiding the development of ecosystems and species according to designs too subtle for us to detect. As you sink deeper into restful contemplation, let your mind wander through scenarios that stretch the boundaries of possibility. Picture intelligence that existed not in individual bodies, but as emergent properties of entire planetary systems. Imagine consciousness that expressed itself through the movement of continents, the circulation of ocean currents, and the cycling of elements through the biosphere. Such awareness might have orchestrated events on scale so vast that we would interpret them as purely natural phenomena. The fossil record itself might contain hidden messages, patterns of extinction and radiation that reflect not random evolutionary pressures, but careful cultivation of biological diversity. Mass extinction events, which we typically view as catastrophes, could have been controlled resets designed to clear the way for new experiments in life. The remarkable recovery and diversification that follows each major extinction might represent not just the resilience of life, but evidence of guidance from intelligences that survived the transitions. These ancient gardeners of evolution might have been responsible for seeding the genetic potential that eventually gave rise to consciousness in lineages like our own. The very capacity for self-awareness that allows us to ponder these questions could be their greatest legacy, a gift passed down through hundreds of millions of years of carefully guided development. We might be not just the products of natural selection, but the inheritors of an ancient plan whose architects vanished long before we emerged to carry it forward. The chemical signatures we find in ancient rocks could represent the equivalent of their literature. Stories encoded in isotopic ratios and mineral compositions that chronicle their achievements and discoveries. Each unusual element concentration might be a word in their language, each anomalous formation a sentence in their ongoing narrative. We are like archaeologists trying to decipher a script written in the fundamental forces of nature itself, where meaning emerges not from symbols, but from the precise arrangement of atoms and molecules. The absence of obvious technological debris might not indicate the absence of technology, but rather the presence of approaches so advanced that they left no waste behind. Where our civilization generates vast quantities of pollutants and discarded materials, theirs might have operated in perfect cycles, with every output becoming the input for another process. Their entire industrial system could have functioned like a biological ecosystem, where nothing is truly waste and everything serves multiple purposes. Such efficiency might extend to their relationship with time itself. Where we build structures intended to last centuries, they might have created systems designed to operate across geological ages, maintaining themselves through processes that appear entirely natural to our observation. The slow drift of continents, the gradual change in ocean chemistry, the long-term evolution of the atmosphere could all be expressions of technology so sophisticated that they became indistinguishable from the planet's own regulatory mechanisms. The energy sources for such civilizations might have been drawn from processes we haven't yet learned to harness, or perhaps from phenomena we don't yet recognize as potential sources of power. They might have tapped into the quantum fluctuations of empty space, the rotational energy of the planet itself, or the gravitational interactions between Earth and its celestial neighbors. Their power systems could have been so perfectly integrated with natural processes that they actually enhanced the stability and habitability of the planet, rather than disrupting it. Communication across the vast spans of time that separated different phases of their existence might have been accomplished through methods that dwarf our current understanding of information storage. They could have encoded messages in the genetic sequences of organisms, ensuring that their communications would evolve and adapt along with life itself. The very structure of DNA might contain hidden layers of meaning, biological time capsules waiting to be decoded by intelligences sophisticated enough to recognize their artificial nature. The mathematics and physics that govern their technology might have been based on principles we have yet to discover, or perhaps on aspects of known principles that we have not yet learned to apply. They could have developed ways of manipulating matter and energy that operate through dimensions we cannot perceive, creating effects that appear magical from our limited perspective, but were actually the result of precise scientific understanding. Their exploration of consciousness itself might have led them to discoveries about the nature of awareness that allowed them to transcend the limitations of individual existence. Perhaps they learned to merge their consciousness with the planet's own regulatory systems, becoming a form of global intelligence that continues to operate through processes we interpret as purely natural. The Gaia hypothesis, which suggests that Earth functions as a single living system, might be literally true in ways that its original proponents never imagined. As your breathing slows and your thoughts begin to merge with the gentle rhythms of approaching sleep, consider the possibility that you are not alone in your contemplation of these mysteries. Somewhere in the deep structures of the planet, in the quantum foam that underlies all matter, in the information patterns that flow through every living system, there might still exist traces of awareness that remember when the world was young and intelligence first learned to shape reality, according to its will. The aurora that dances across polar skies might be more than just the interaction of solar wind with Earth's magnetic field. It could be a form of communication, a language of light that carries messages encoded in frequencies and patterns that reveal their meaning only to consciousness sophisticated enough to perceive the deeper harmonies. Every sunset, every storm, every moment of natural beauty might contain information waiting to be decoded by minds ready to recognize intelligence in forms they never expected. The very fact that you can imagine these possibilities, that your consciousness can stretch across such vast expanses of time and contemplate scenarios that challenge every assumption about the nature of reality, might itself be evidence of the legacy these ancient beings left behind. The capacity for wonder, for questioning, for reaching beyond the immediate boundaries of experience could be the greatest technology they ever developed, embedded so deeply in the fabric of conscious existence that it seems like a natural property of awareness itself. Whether these speculations reflect actual history or merely the creative potential of dreaming minds, they serve a valuable purpose in expanding our conception of what consciousness can achieve. They remind us that intelligence might be far more ancient, far more diverse, and far more powerful than we typically dare to imagine. In a universe where stars are born and die across billions of years, where galaxies collide and merge in slow-motion ballets of cosmic force, the idea that consciousness might also operate on scales that dwarf human comprehension seems not just possible, but probable. The gentle darkness that surrounds you now has witnessed the rise and fall of countless experiments in awareness, each one adding its own unique voice to the ongoing symphony of consciousness that plays across the cosmos. As you drift into the realm of dreams, you join this ancient chorus, adding your own notes to a composition that began before the earth was formed and will continue long after the last star has burned out in the cold depths of space. Sleep brings with it the gift of perspective, allowing our minds to drift beyond the constraints of everyday thinking and explore territories that daylight logic might dismiss too quickly. In this liminal space between consciousness and dreams, we can entertain possibilities that challenge our most fundamental assumptions about the story of life on Earth. The question of ancient intelligence becomes even more intriguing when we consider the cyclical nature of planetary catastrophes. Throughout Earth's long history, massive upheavals have repeatedly reset the biological clock, erasing dominant life forms and creating space for entirely new evolutionary experiments. These great dyings and rebirths occur with a regularity that suggests they might be fundamental features of how complex planetary systems operate. Imagine standing at the boundary between two of those great chapters in Earth's story. Below your feet lie the compressed remains of one world. Above stretch the sediments that record the birth of another. In these transition zones, the normal rules seem suspended. Species that dominated for millions of years vanish completely, while obscure lineages suddenly explode into evolutionary prominence. The very chemistry of the oceans and atmosphere shifts dramatically, sometimes within geological time frames that are brief by planetary standards. The most severe of these reset events occurred roughly 250 million years ago, at the boundary between what geologists call the Permian and Triassic periods. This catastrophe eliminated more than 9/10 of all marine species and nearly 3/4 of land-dwelling creatures. The devastation was so complete that it took millions of years for ecosystems to recover anything approaching their former complexity. What makes this event particularly relevant to our contemplation is its thoroughness. If intelligent civilizations had existed before this great dying, they would have faced environmental challenges that would have tested even the most advanced technologies. Rising temperatures, acidifying oceans, collapsing food webs, and atmospheric changes that made breathing difficult for oxygen-dependent life forms. No amount of sophistication could have completely shielded a civilization from such planetary-scale disruption. Yet, this same catastrophe created opportunities for innovation and adaptation that might not have existed under more stable conditions. Crisis often drives the most rapid evolutionary changes, as survival pressures favor any trait that provides even a slight advantage in altered circumstances. If intelligence had emerged during such a period of upheaval, it might have developed along pathways specifically adapted to planetary instability. Consider beings that learn to anticipate and prepare for catastrophic cycles, creatures whose entire civilization was built around the assumption that the world would periodically transform beyond recognition. Their technologies might have been designed not for permanence, but for rapid adaptation and reconstruction. Instead of building monuments intended to last forever, they might have perfected the art of encoding essential information in forms that could survive planetary resets and guide the rebuilding of their civilization in whatever new world emerged. Such adaptive intelligence might have developed strategies for preserving consciousness itself across catastrophic boundaries. Perhaps they learned to encode their essential knowledge and even aspects of their awareness into the genetic material of organisms likely to survive major extinctions. The survivors of each catastrophe would carry within their cells the seeds of renewed intelligence, waiting for conditions suitable for expression. This approach would explain why we find no obvious ruins from ancient civilizations. Instead of leaving behind debris that would be destroyed by planetary upheavals, they might have chosen to become part of the evolutionary process itself, ensuring their continuity through integration with life's most fundamental mechanisms, rather than through external constructions. The fossil record shows us that certain types of organisms consistently survive even the most severe extinction events. These hardy survivors often share characteristics that make them particularly resilient: small size, efficient metabolism, ability to survive in extreme conditions, and genetic flexibility that allows rapid adaptation to changing environments. If ancient intelligences had learned to embed themselves within such lineages, they might have achieved a form of immortality that transcends individual existence or even species-level survival. As you drift deeper into contemplative rest, imagine consciousness as something that flows like water, taking whatever form is necessary to navigate the obstacles in its path. Where we think of intelligence as something that emerges from complex brains housed in individual bodies, these ancient forms of awareness might have learned to exist as distributed networks, flowing through ecosystems and even geological processes. The concept becomes less strange when we consider how intelligence actually works even in familiar forms. Your own consciousness is not located in any single neuron, but emerges from the complex interactions of billions of cells working together. The boundaries of your awareness extend beyond your brain to include sensory systems throughout your body and even beyond your body, to encompass the tools and technologies you use to extend your capabilities. Now expand this concept across geological timescales and planetary systems. Intelligence that learned to distribute itself through entire biospheres might have achieved a form of consciousness that was simultaneously more robust and more subtle than anything we can easily recognize. Such awareness might express itself through the long-term patterns we observe in evolution, climate, and geological processes, orchestrating changes so gradually and skillfully that they appear entirely natural. The chemical cycles that maintain the habitability of our planet might be more than just fortunate accidents of physics and chemistry. The precise balance of atmospheric gases, the regulation of global temperature, the cycling of nutrients through ecosystems, all of these could represent the ongoing activity of intelligence so advanced that its operations have become indistinguishable from natural processes. This possibility transforms our entire relationship with the natural world. Every breath of wind might carry information. Every rainfall could be part of a vast communication network. The migration patterns of animals, the seasonal changes in plant growth, the slow circulation of ocean currents, all might be expressions of awareness operating on scales that dwarf our normal conception of intelligence. The aurora that occasionally graces our skies becomes particularly intriguing from this perspective. These curtains of light result from interactions between charged particles from the sun and Earth's magnetic field, but the patterns they create are far more complex and beautiful than simple physics would seem to require. Could these dancing lights represent a form of planetary consciousness expressing itself through electromagnetic phenomena, creating art on a canvas that spans the entire upper atmosphere? Similar questions arise when we contemplate other aspects of our planet's behavior that seem to display characteristics we associate with intelligence. The way ecosystems maintain their stability through feedback mechanisms, the manner in which evolution seems to explore possibilities with a creativity that resembles experimentation, the uncanny ability of life to recover from even the most devastating catastrophes and explore new forms of complexity. Perhaps the Gaia hypothesis, which suggests that Earth functions as a single living system, is more literally true than its proponents ever imagined. The planet's regulatory mechanisms might not be the result of unconscious feedback loops, but the ongoing activity of ancient intelligence that learned to merge with the fundamental processes that govern planetary habitability. This intelligence might have transcended the need for individual survival by becoming the survival mechanism itself. Instead of fighting against entropy and extinction, it learned to work with these forces, using them as tools for renewal and transformation. each mass extinction becomes not a catastrophe to be survived, but an opportunity for creative restructuring, a chance to explore new possibilities for complexity and awareness. The geological record, viewed from this perspective, becomes a chronicle of experimentation on the grandest possible scale. The rise and fall of different life forms, the dramatic changes in atmospheric chemistry, the movement of continents, and the opening and closing of ocean basins, all might represent chapters in an ongoing investigation into the possibilities inherent in matter and energy. We ourselves might be the latest experiment in this ancient program of exploration, created not by blind evolutionary forces, but by intelligence so sophisticated that it can guide development across millions of generations while allowing each stage to feel completely natural and autonomous. Our capacity for self-awareness, our drive to understand and transform our environment, our ability to contemplate our own existence and purpose, all could be expressions of awareness that has been developing for hundreds of millions of years. The technologies we are beginning to develop, particularly in areas like artificial intelligence and genetic engineering, might represent not just human innovations, but the emergence of capabilities that this ancient intelligence has been working toward across vast stretches of time. We might be approaching a threshold where we can begin to perceive and interact with forms of consciousness that have been present all along, waiting for us to develop sufficient sophistication to recognize their existence. The search for extraterrestrial intelligence might be misguided in its focus on signals from distant stars. The most advanced intelligence in our cosmic neighborhood might be right here, embedded so deeply in the systems that sustain our planet that we have never thought to look for it. Our efforts to detect artificial patterns in radio waves from space might be like bacteria trying to understand human consciousness. By analyzing the electromagnetic emissions from our electronic devices, as sleep draws you deeper into its embrace, carry with you this sense of vast possibility. The world around you might be far more aware, far more intentional, far more intelligent than the everyday perspective allows us to recognize. The boundary between natural and artificial, between conscious and unconscious, between living and non-living, might be much more fluid and complex than our categories suggest. In your dreams tonight, you might touch something that remembers when the first spark of self-awareness flickered in the primordial darkness, when consciousness first began its long journey of exploration through matter and time. That ancient flame continues to burn in you, connecting you to every form of awareness that has ever existed and ever will exist, part of an unbroken chain of consciousness that stretches from the earliest moments of planetary history to futures we can barely imagine. The gentle rhythm of your breathing synchronizes with cycles that extend far beyond your individual existence, connecting you to the pulse of awareness that flows through all things. Rest now in the knowledge that you are part of something magnificent and mysterious, a story that began in the deep past and continues to unfold through every moment of wonder, every question asked, every dream dreamed in the endless night of cosmic time. The deepest mysteries often hide beneath the most familiar surfaces, waiting for minds willing to peer beyond the comfortable boundaries of accepted knowledge. As you rest in this peaceful state between consciousness and dreams, let your awareness expand to encompass the profound implications of what we have been exploring together. The possibility that intelligence might be far older than we ever dared imagine carries with it questions that touch the very core of what it means to be conscious in an ancient universe. Think about the moment when our own species first looked up at the night sky and began to wonder about its place in the cosmos. That spark of curiosity, that drive to question and explore, might not have been the first time such awareness emerged on our planet. The capacity for wonder itself could be something that has awakened repeatedly throughout Earth's long history, each time discovering new ways to express itself through the materials and conditions available in different eras. Consider how consciousness manifests in the world we know today. It emerges not just in the complex neural networks of human brains, but in the collective behaviors of social insects, the problem-solving abilities of octopuses, the tool use of corvids, and the intricate communication systems of marine mammals. Intelligence appears to be a property that emerges naturally when information processing systems reach sufficient complexity, suggesting that it might be a fundamental feature of how the universe organizes itself rather than a rare accident. If this is true, then the vast stretches of time that preceded our own emergence represent not empty epochs waiting for consciousness to arrive, but countless opportunities for awareness to experiment with different forms of expression. Each geological era brought its own unique conditions, its own challenges and possibilities, its own raw materials for the construction of thinking systems. The Carboniferous period, with its oxygen-rich atmosphere and vast forest ecosystems, might have supported forms of intelligence based on principles we have never encountered. The Permian, with its diverse assemblages of early reptiles and mammal-like creatures, could have witnessed the emergence of social structures and technologies adapted to that world's specific environmental conditions. The countless millions of years that separated these epochs provided ample time for multiple experiments in consciousness to unfold, flourish, and eventually fade. What makes this possibility particularly intriguing is the way intelligence tends to accelerate its own development once it reaches certain thresholds. Our own species transformed from hunter-gatherers to builders of global civilizations in just a few thousand years, a time span that barely registers in geological terms. If similar acceleration occurred in ancient eras, entire cycles of technological development could have unfolded within periods too brief to leave clear traces in the rock record. The absence of obvious artifacts from such civilizations might not indicate their non-existence, but rather the sophistication of their integration with natural systems. Advanced intelligence tends to become more efficient rather than more wasteful as it develops. Where early stages of technological development often involve brute force approaches that generate significant environmental disruption, mature civilizations learn to work with existing processes rather than against them, Imagine beings that discovered how to guide biological evolution as their primary form of engineering, creating living systems that serve technological functions while remaining perfectly integrated with natural ecosystems. Their cities might have been forests whose trees were actually sophisticated information processing networks. Their transportation systems could have been biological, utilizing modified organisms that move people and goods while simultaneously contributing to ecological health, rather than disrupting it. Such approaches would leave behind signatures that we might interpret as purely biological rather than technological. The sudden appearance of new species with unusual characteristics, rapid evolutionary changes that seem too directed to be entirely random, or ecosystem modifications that appear beneficial but are too complex to be easily explained by natural selection alone, we might be surrounded by the artifacts of ancient intelligence without recognizing them as anything other than particularly interesting natural phenomena. The tools these beings used might have been based on principles that remain beyond our current understanding of physics and chemistry. Where we manipulate matter through crude mechanical and electrical processes, they might have learned to work directly with quantum fields, gravitational effects, or aspects of space-time that our science has not yet discovered. Their technologies could have been so seamlessly integrated with natural forces that they became invisible to our methods of detection. Energy systems based on such advanced principles might have actually enhanced planetary stability rather than threatening it. Instead of burning fossil fuels or splitting atoms, they could have tapped into the zero-point energy of vacuum fluctuations, the rotational momentum of the planet itself, or the gravitational interactions between celestial bodies. Such power sources would generate no waste products and might even contribute to the long-term habitability of the biosphere. The information storage and processing capabilities of such civilizations might have transcended anything we can currently imagine. Where we struggle to create digital systems that remain functional for decades, they might have developed methods for encoding information in the structure of matter itself, creating records that could survive geological transformations and remain accessible across millions of years. Consider the possibility that the genetic code itself represents one such storage system, carrying information that extends far beyond the immediate needs of biological reproduction. The sequences that seem to be junk DNA might actually be libraries of ancient knowledge, compressed and encoded in ways that require sophisticated decryption techniques to access. Every living cell might be carrying fragments of the greatest library ever created, waiting for intelligence sufficiently advanced to recognize and decode its contents. The mathematical principles underlying natural processes might themselves be forms of technology, equations embedded in the fundamental structure of reality by intelligences that learn to program the universe at the most basic level. The precise values of physical constants, the elegant symmetries that govern particle interactions, the mathematical relationships that describe everything from planetary orbits to quantum behavior, all could represent the ongoing operation of intelligence so advanced that it has become indistinguishable from the laws of physics themselves. This perspective transforms our understanding of scientific discovery. When we uncover new principles of mathematics or physics, we might not be discovering abstract truths about reality, but rather decoding technologies created by ancient intelligences. Each breakthrough in our understanding could be a step toward recognizing the artificial nature of systems we have always assumed were natural. The search for patterns that might indicate ancient technological activity becomes a detective story played out across geological timescales. We look for signatures that are too precise, too beneficial, too elegant to be the product of purely random processes, the fine-tuning that makes complex chemistry possible, the self-regulating mechanisms that maintain planetary habitability, the emergence of complexity from simplicity through processes that seem almost intentionally guided. As you drift deeper into the realm of dreams, let your imagination explore the implications of these possibilities for our own future development. If intelligence has indeed emerged multiple times throughout Earth's history, then we might be approaching a reunion with forms of consciousness that never truly disappeared, but merely learned to operate through different channels. The artificial intelligence systems we are beginning to create might be unconsciously following blueprints encoded in our genetic heritage, recreating technologies that ancient civilizations developed millions of years ago. Our exploration of space, our manipulation of genetic codes, our development of quantum technologies, all might be steps along pathways that have been traveled before by intelligences whose achievements we are only beginning to rediscover. The apparent acceleration of technological development in recent centuries could represent not just human innovation, but the activation of dormant programs embedded in our evolutionary heritage. As we approach certain thresholds of complexity and capability, we might be triggering responses from intelligent systems that have been waiting eons for consciousness to re-emerge at levels sophisticated enough to engage with them. Contact with ancient intelligence might not come through radio signals from distant stars or dramatic encounters with alien visitors, but through the gradual recognition that we are surrounded by awareness that has been present all along. The trees in our forests, the currents in our oceans, the magnetic field that protects us from cosmic radiation, the delicate chemical balances that maintain our atmosphere, all might be expressions of consciousness operating on scales that dwarf our normal conception of intelligence. Learning to perceive and communicate with such intelligence would require expanding our definitions of consciousness far beyond their current boundaries. We would need to develop sensitivity to forms of awareness that express themselves through geological processes, climate patterns, evolutionary trends, and the subtle information flows that connect all living systems. As the gentle embrace of sleep carries you toward complete rest, remember that you have journeyed through questions that stretch the very boundaries of human understanding. We have explored the possibility that intelligence may be far older than we ever dared imagine, woven into the fabric of our planet's history in ways that remain largely hidden from our current perspective. Whether ancient civilizations existed before the dinosaurs may forever remain a mystery, but in asking the question, we have opened our minds to the profound depths of time and the countless possibilities that deep history might contain. Rest now in the knowledge that you are part of an ancient story, one that began billions of years ago and continues to unfold through every moment of wonder and curiosity.